Let's solve this carefully and find the actual shaded area. We have a large circle with a semicircular section removed from the top. The distance from the top of the large circle down to the diameter of the smaller semicircle is 2 units, and the distance from the bottom of the smaller semicircle down to the bottom of the large circle is 4 units. We want the area of the shaded region. Let the radius of the large circle be capital R, and let the radius of the smaller semicircle be lowercase r. Before calculating the area, we need to find these 2 radii. Let's use the geometry of the chord and a right triangle. The full diameter of the large circle is made from the top segment of 2 units, the radius of the smaller semicircle of r units, and the bottom segment of 4 units. Therefore, the diameter is 2 plus r plus 4, which gives 2r equals r plus 6. From this we can write r equals 2r minus 6. Now let's use the chord of the smaller semicircle. Its half length is r, and if we connect the center of the large circle to one endpoint of this chord, we get a right triangle. The hypotenuse is the large radius, capital R. The horizontal leg is the smaller radius, lowercase r. What about the vertical leg? The chord is 2 units below the top of the large circle, so the distance from the center of the large circle to the chord is capital R minus 2. By the Pythagorean theorem, the square of the horizontal leg plus the square of the vertical leg equals the square of the hypotenuse. Therefore, r squared plus the quantity r minus 2 whole squared equals r squared. Now substitute r equals 2r minus 6. We get the quantity 2r minus 6 whole squared plus the quantity r minus 2 whole squared equals r squared. Expanding the first square gives 4r squared minus 24r plus 36. Expanding the second square gives r squared minus 4r plus 4r. So we have 4r squared minus 24r plus 36 plus r squared minus 4r plus 4 equals r squared. Combine the like terms. This gives 5r squared minus 28r plus 40 equals r squared. Now subtract r squared from both sides, giving 4r squared minus 28r plus 40 equals 0. We can divide every term by 4, so we get r squared minus 7r plus 10 equals 0. Now, factor the quadratic. We need 2 numbers whose product is 10 and whose sum is negative 7. Those numbers are negative 5 and negative 2. Therefore, the equation factors as the quantity r minus 5 multiplied by the quantity r minus 2 equals 0. So capital R equals 5 or capital R equals 2. But remember, r equals 2, r minus 6. If r equals 2, then r would equal 4 minus 6, which is negative 2, and a radius cannot be negative. So r equals 2 is not physically possible. Therefore, the large radius is 5 units. Now substitute this into r equals 2r minus 6. We get r equals 2 multiplied by 5 minus 6, which gives 10 minus 6, so r equals 4 units. Now we can finally calculate the shaded area. The area of the large circle is pi multiplied by r squared, so it is pi multiplied by 5 squared, which equals 25 pi square units. The area removed is a semicircle, so we take half of pi multiplied by r squared. Since r is 4, this becomes 1/2 multiplied by pi multiplied by 4 squared. 4 squared is 16, and half of 16 is 8. So the semicircle has an area of 8 pi square units. The shaded area is the area of the large circle minus the area of the semicircle. Therefore, the shaded area equals 25 pi minus 8 pi, which simplifies to 17 pi. So the final answer is 17 pi square units.